Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 7th question from the mid-year examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 9 videos, since the question paper had 9 questions in total. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, question 7. We are told that the siren of a rescue vehicle emits waves at a frequency of 360 hertz. Okay, so the frequency of the source is just 360 hertz, and then the frequency of the sound, as heard by a listener standing along the road, is just 450 hertz, 405 hertz, right? So the frequency detected by the listener is 405 hertz. Before guys, I even answer the following questions. Since the frequency detected by the listener is greater than the frequency of the source, it simply means that the rescue vehicle is moving towards the stationary listener who is standing. Are you together? Whenever guys the frequency detected is greater than the frequency emitted by the source, that means there is towards movement. Either the source is moving towards the stationary listener, or the listener is moving towards the stationary source. So in this case of ours, our rescue vehicle, which is the source, is moving towards a stationary listener. Okay, so now let's answer the questions. They want us to define Doppler effect. Doppler effect, guys, is just an apparent change in the observed frequency of the source as a result of relative motion between the source and the observer. Is the apparent change in the observed frequency of the source as a result of relative motion between the source and the observer. Okay, and then now we are being asked, was the rescue vehicle towards or away from the listener? It was moving towards the listener. Are you together? And then they want us to explain the answer, making specific references to frequency, wavefronts, and wavelength. Okay. As the vehicle, guys, is moving towards, since the listener detects a higher frequency, it simply means that the rescue vehicle is moving towards the listener. Are you together? And hence the wave fronts that are formed when the vehicle is approaching the listener will be compressed. The wave fronts will be compressed, and hence the wavelength will be lesser. Are you together? The wavelength detected by the listener will be less than the wavelength emitted by the source. Are you together? Please do note that as the siren, or rather as the rescue vehicle approaches the listener, the wave fronts will be more compressed, and hence the wavelength detected by the listener will be smaller than the wavelength emitted by the source. And that is why, guys, the frequency is greater than the frequency of the source. Are we together? Okay, and then now they want us to take the speed of sound in air as 340 meters per second to calculate the speed of a rescue vehicle that was moving. Okay, let's write down our data. The frequency observed, it's given to us as 405 hertz. The frequency of the source is 360 hertz. The speed of the listener was standing, so the listener had a speed of 0 meters per second, and the source had a speed of that's what we are looking for. Then the speed of sound in air is just 340. Are you together? Okay, we are simply going to use our Doppler effect equation. It says frequency of the listener is V plus minus VL, all over V plus or minus Vs multiplied by frequency of the source, right? Okay, frequency of the listener. Remember that, guys, we are told that the listener was stationary, né? So at the top, I know that this will be 0 meters per second. So I'll just be left with V all over V and Vs over there multiplied by Fs. I want to know which sign am I supposed to choose between plus or minus. If, guys, the source is moving towards a stationary listener, I'm supposed to use a minus there at the top, at the bottom rather. It's together. And then now the only unknown I have is my velocity of the source. Let me just substitute. This is 405 being equal to 340 all over 340 minus Vs multiplied by 360. Right, together. So I'll simply cross multiply over there. I'll have 405 multiplied by 340 minus Vs is just equal to 340 multiplied by 360. Right, together. And hence, if I divide both sides by 405, I'll be left with 340 minus Vs is equal to 340 multiplied by 360 all over 405. Okay, and then if I take this number over here to the left hand side, I'll end up having 340 minus 340 times 360 all over 405 is equal to, if I take the Vs to the other side, it will be positive. That's just Vs. Therefore, the velocity of my source is basically equal to the velocity of my source is just 340 minus 340 times 360 all over 405. So the speed of the source was just 337.78 meters per second. So the speed of a rescue vehicle was just 37.78 meters per second. Okay. Then now we are told that the driver of a rescue vehicle continue at this speed past the stationary listener. What changes, if any, if any changes would occur in the following? Write down the values of the frequency of the siren heard by the driver, the frequency observed by the listener, the speed of the sound in air. Okay. The frequency, guys, the frequency of the siren, or rather the frequency of the source heard by the driver, since the driver is the one that is transporting, or since the driver is inside the driver is inside our sound source, the frequency will never change. Are you together? So the frequency that will be heard by the driver will still be equal to 360 hertz. Okay. The frequency observed by the listener, the driver of the rescue vehicle continues at the speed past the stationary listener. What changes if, okay, obviously, guys, the frequency will change. Are you together? The frequency detected by the listener will change as the driver moves away, and the speed of sound will just remain the same. Let me erase over there. The speed of sound will simply remain the same because we do not change the environment. So the speed of sound will still have 340 meters per second, and then the frequency observed by the listener will change, guys. Ne? If the listener is moving away, what about the driver moves past the listener? Okay, as the driver is passing the listener, guys, ne, they will detect the same frequency. Are you together? If this is our listener over here, are you together? And then the driver passes the listener, the driver is approaching the listener, moving towards, and then this is the driver and the listener, and then the driver moves away from the listener. When the driver is at the same position with the listener, the frequency observed by the listener will simply be equal to 360 hertz. It's good. The frequency observed will be 360 hertz, but as the driver moves away from the listener, the frequency will decrease. The frequency observed by the listener will definitely be less than 360 hertz. So that's how, guys, you could have tackled this Doppler effect equation. So please do share the video, guys, to your peers. And yeah, just wait for more videos. Thank you.